All right, this is the infamous baseball problem, right? The thing that makes this tricky is that, here's this poor guy batting, right? Baseball comes flying at them. Oh, you got to give him a bat. Holding it with one hand. What do you expect? Okay, that's because he's holding a beverage in the other hand. Here's your Uncle Walter at the family softball game. Okay, not taking the sport too seriously. Here's the pitcher, right? They pitching the ball, right? So it goes this way, that 41 meters per second. And Unker, this guy's got a heck of a pitch. That's more than 90 miles per hour, right? It's 41 meters per second that way, right? And then they hit it 53 meters per second. They pow, they hit it straight back. Line drive, right? Okay, and that is this way. Now, resist the temptation. We're just still going to use this same formula. Force times time is mass times change in velocity, right? And we've got the mass of the baseball, right? 0.142. And we've got the force that the bat exerted, 23. Right? It's what we're trying to find the time, right? Okay. But now the trick is, what's the change in velocity? Let me convince you that this change in velocity is not 12 or something like that. We do not want to subtract these numbers. We actually want to add them, and here's why. If we make a number line here, ooh, that's a very straight number line, right? Okay, 0 is here, and this velocity would actually be negative 41 because it's going to the left. Okay, so negative 41, and then when they hit it, it goes out here at positive 53. Convince yourself that this change here is quite large. Okay, that change there is, what is that? That's plus 94 meters per second. Okay, so it's a huge change when it changes direction. And this is why, of course, the ball that bounced off the block was better at knocking it down, because it was a bigger change in velocity than just stopping. It's a bigger change to stop and turn around and go the other way. Okay, so this is plus 94, and now we're set, right? This is newtons, this is kilograms, this is meters per second, and we're all set. We can find the time. So 0.142 times 94 divided by 2350 is 0.00, so the time is 0.00568, or what is that? That is 5.68 milliseconds. Wow, that's crazy. Okay, so the math here was this times this, and then divide by this. Okay, all right. So just remember, when you've got these things, if they turn around and go back the other way, that's that 94, that change in velocity is 41 plus 53. And they'll all be like that. Every single one with a baseball hitting it straight back out. You're going to add those two velocities because one is one way, the other one's the other way. It's a huge change in velocity. That's the key. Don't forget that. I mean, it's going to be on the test. It's going to be on the test.